This lecture will go through some examples of solving trigonometric equations. So what happens is you'll need to have a pretty thorough knowledge of the unit circle so that once you get it down to where you've gotten past a lot of the algebra, you can solve your equation. But also you'll have to use a lot of algebra, particularly factoring techniques, a few other things we'll see later, some trig identities as well. So this is an example that's already factored. So we've got the equation tan x times tan x minus 1 is equal to 0. So since it's factored, we know that solutions will be tan x equals 0 and tan x equals 1, this one and this one. If tan x equals 0, then that's places such as 0, pi, and 2 pi. We know that from our unit circle. And if we want to generalize this, we can say that's k pi, where k would be an integer. And sometimes we'll look to generalize the solution. Sometimes we'll just go for solutions between 0 and 2 pi. Now tan x equals 1 at places such as pi over 4, 5 pi over 4. So that would be first and third quadrant spots. So here and down here. If we want to generalize that, we could say pi over 4 plus k pi because we go around multiples of pi. So there's our general solution, k pi and pi over 4 plus k pi. If we just wanted between 0 and 2 pi, usually we go from 0, but we don't include 2 pi, we would have just those 4 answers. Okay, here's another one. We have 2 sine squared x equals 2 plus cosine x. Now, it's the sign, you want to think of this as a quadratic equation, but the problem is you have sines and cosines. It's hard to change cosines into sines, but it's easy to change sine squareds into cosine squareds using the Pythagorean identity. Cosine squared plus sine squared equals 1. So sine squared is 1 minus cosine squared. We leave this part as it is, except we're going to move it all to the left, so that now we have everything on the left. So this is now a quadratic equation in cosine. So I simplify it, quadratic equation in cosine. So just like you do any quadratic equation, in this case you can factor it. So I'll factor out a negative cosine. I'm left with 2 cosine x plus 1, that's equal to 0. So I have a couple possibilities here, one of which is when this piece is equal to 0, so cosine x is equal to 0. The other one is when 2 cosine x plus 1 is equal to 0, which if I subtract 1 and divide by 2, gives me cosine x is equal to negative a half. Cosine x is 0 at the top and bottom of the unit circle, so that's going to be pi over 2 and 3 pi over 2. It's equal to negative and a half, quadrants 2 and 3, so it's 2 pi over 3 and 4 pi over 3. So those are my 4 answers just from 0 to 2 pi. That's not a general solution. Okay, this particular one illustrates another way of doing a problem, sines and cosecants. It's best just to let's see. The way I tried it, there's often different ways to do it. I multiplied both sides by sine, or basically I multiplied the entire equation by sine. And so distributing, now I get 2 sine squared. And because cosecant is 1 over sine, then sine times cosecant becomes just plus 1. These just become 1. And sine times 0 is 0. You have to be careful, though, not to introduce extraneous solutions when you do something like this. So then I'm going to subtract 1 and divide by 2. So I get sine squared is negative a half. Then I take a square root, but the problem is you can't have sine squared and get something negative. It's impossible to square something and get a negative answer. So this actually has no solutions. Okay, this is an example of a problem of multiple angles where it's tan 3x. And let me go through with you what I did here. First, forget about the 3x. Just think about where tangent's equal to 1. Tangent's equal to 1 in the first unit circle, 0 to 2 pi at pi over 4 and 5 pi over 4. But the thing is, this is now 3x, not x, so we set 3x equal to pi over 4, and we set 3x equal to 5 pi over 4. And since we're actually trying to get x, we've got to divide both sides by 3, so pi over 4 becomes pi over 12, 5 pi over 4 becomes 5 pi over 12. So good, that's 2 answers, but the problem is if you want every answer from 0 to 2 pi, you got to go around the circle more times. Because of this dividing by 3, you're going to have more solutions that you'll miss otherwise. So we have pi over 4 and 5 pi over 4. If we go around, keep going around, we get to 9 pi over 4. We divide that by 3 because we want to get x, not 3x. So that gives me 3 pi over 4, which is between 0 and 2 pi. Then I'll keep going around. I get to 13 pi over 4. I divide that by 3. It's 13 pi over 12. I go around and get another half turn, 17 pi over 4, which becomes 17 pi over 12. One more half turn, I get to 21 pi over 4, which is 7 pi over 4. So I got these 6 answers. If I were to go farther, past these 3 revolutions, and notice this is a 3, it's usually going to be the same. If I keep going, I get to 25 pi over 4, which becomes 25 pi over 12, which is bigger than 2 pi. So if you only want answers between 0 and 2 pi, You got to go around these 3 times, no more and no less. Now, this is sort of the opposite situation where now it's a half angle instead of a multiple angle. And so, again, find out where cosine is equal to rad 2 over 2. That's going to be at pi over 4 and at 7 pi over 4. But that's not for x, that's x over 2. So to get x, you got to multiply both sides by 2. So pi over 4 becomes pi over 2. 7 pi over 4 becomes 7 pi over 12, which is too big. That's bigger than 2 pi, so I cross it out. So this equation has only one solution, pi over 2, between 0 and 2 pi. Just the one solution. Okay, tan squared x minus 8 tan x plus 13 equals 0. You can't factor it, so it's a quadratic equation in tangent, so we use the quadratic formula right here, where our variable is tan x, our b is negative 8, our a is 1, our c is 13. We plug it into the quadratic formula and get all this. And so tan x is 8 plus or minus 2 rad 3 over 2, which reduces to 4 plus or minus rad 3. And so to find these spots, inverse tan of 4 plus rad 3 is somewhere here in the first quadrant. So that'll be this spot. Got to find it with the calculator. And you got to add pi to get the corresponding spot in the third quadrant. Inverse tan of 4 minus rad 3 is somewhere over here in the first quadrant. So you get that from the calculator, then add, again, pi to get the corresponding spot here in the third quadrant. And finally, this is one you have to use a calculator for. There's no way to do this analytically. Y equals cosine squared x, y equals e to the negative x plus x minus 1. What you're trying to do basically is find the solution to the equation when you set these guys equal to each other. And so the way to do it is to graph the two of them. You graph them, and you see where they intersect. And so you graph them. Here's the exponential. Here's the cosine squared. Use second calc, intersect with your calculator, and you get 0.951 approximately. So that one has to be done using some device such as a calculator.